Awesome. Okay. So this is our SQL workshop. It's presented by Jackson Leung. He actually is our previous president from, is it 3 semesters ago or 4 semesters?
Might be three.
Three? Okay,
I was
semesters.
spring 2019. So that's
Yes, spring 2019. I think Jackson was the president when I first got on the board, so it's always nice to see him back and be here with us. Uh, Continuing on. As I said before, this is a really good refresher course for ISDS 402 or just relearning SQL. It really helps with interviews and it really helps you just have a reference back when you need to relearn stuff. But before we start, I just have one announcement. As you guys know, I mentioned it last week. We have our second competition. So this is basically, it'll consist of you guys receiving a data set from us on November 14th at 1. And you'll be able to do anything with it. You could do data visualization. You could give us some insights that you notice from the data. Uh, just anything that you might see fit that anyone might find of value with the data set. Um, so I recommend everyone taking this competition. It really helps you find out like where you are level wise of what you need to know. If you don't know too much if you don't know too much about data yet, like that's completely fine. It's really good to just get yourself exposed to this kind of setting so you're able to explore it in your free time and know like what things people might look out for. So as you can see, anyone can participate. So undergraduates, graduates, even alumni, we're opening it up to them if they see fit to it. Um, you can enter as an individual or a team of two. The sign up link will be coming this at the start of next week. I still have to create it, but it'll be there in the general chat in Slack. And we have prizes, really cool, for three random participants. So just giving a submission on November 21st will enter you into that opportunity drawing. So it's really good to receive that prize and it's nothing intimidating. It's just as long as you participate, you get that. So far for prizes that we are thinking of we are thinking of doing Echo Dot, AirPods, and also another gift card, probably something more of the participation ones. But uh, it is really good to just put yourselves out there. Even if you don't win or get anything, I think you'll definitely get the experience out of it and it'll help you know where you are and what you need to learn about data. Does anyone have any questions about it? Uh, Questions, answers. All right. Super cool. Okay. That's just one of my announcements. So I will be handing it off to Jackson. Let me pause my share. Okay, Jackson, you should be good to share.
okay.
Mhm. And if at any point you need me to pause the recording, just let me know and I'll do that for you.
Sure. Yeah, no problem. Uh, hold on. Am I sharing correctly? I
Yes.
feel like an old person. Okay. All right. Hello, everyone. So my name is Jackson. I'm a data scientist from Skyworks Solutions. I was, like Kevin said, I was president in spring of 2019. It felt like a while ago. And I've been doing this SQL workshop for, I think, a few semesters, I think 4 times for this club. And so with that, I'm not exactly sure how many of you have SQL Server Management Studio installed right now, or if you're on Mac OS Azure Data Studio. I know this is something we usually work out beforehand. Kevin, do you know if was this given out instructions to install?
No.
If not, it's fine.
Let
Yeah,
me go get the download link for the members. Give me one
sure.
second.
And let me just copy and paste the link to the PowerPoint. Sorry, I'm okay. Well, out of the way. So if you want to go to the PowerPoint, it is at bit.ly/bdac_SQL, all caps. Uh, it's not necessary to, if you could follow along, if you have this installed, you can follow along. If not, that's fine. This is all recorded. I'll have instructions at the very end on how you could create your own database and run all these queries for yourself. So first off, what is SQL? SQL is short for Structured Query Language, and it is the language that we use to interact with a relational database management system, or a RDBMS. Consists of four sublanguages. Uh, we have your data query language, DQLs, your data definition languages, data control language, and data manipulation language. We'll be doing, or most of the time, if you're doing SQL for data analytics, you'll mainly be working with the data query language, which is what we'll be going over today. Not so much the data definition language, which is like creating tables and such. Although you may be doing that in your job. So why learn SQL? So it's the most commonly used language for data retrieval. Uh, you hear some people talking about like NoSQL or anything like that. Um, like SQL by far is uh, widely used and probably will be used for as long as I could see, and super important to know. You can, instead of relying on other people to get data for you, you can get your own data and you can answer your own questions, which becomes really important. It's very efficient for handling large amounts of data. You could do calculations on like millions of rows of data in like, a fraction of a second. Whereas if you try to do the same in Excel, if you got like say half a million rows in Excel, just copying and pasting that into Excel would take you forever, let alone doing any kind of calculation. And the nice thing about it too, about SQL, since all the code is written down, it could be reproducible and reran anytime to produce, to give updated results for a report. And so this here is just a chart I found online. It pretty much extracted the top keywords from data scientist job listings on, I believe this was on LinkedIn. At the top, you have Python and R, followed closely by SQL. And Python and R, a lot of these can be interchangeable in a lot of job listings, but you can see just how high SQL is. I mean, if you're going to do data analytics or data science work, I mean, data is obviously a big part of it, and getting your own data is super important. So what is a database? So a database is a structured set of data held on a computer or a server, and it can be accessible in various ways. It can be relational or non-relational. This table or this database that I'll be working with today is a relational database. And a relational database is a collection of normalized tables where, if some of you guys have taken your SQL courses, you'll know that a normalized table is something that will follow like what, third or fourth normal form, I believe. And so what is a table? A table is a collection of related data held in a structured format within a database. It consists of rows, also known as records, and columns, otherwise known as fields. And so this here is just an example of one. Each row is a record, and each of these columns is I guess, a characteristic of that record. So then if you were following along, or if you're following along rewatching this, I'll show you how to connect to the server. In this particular example, let me just disconnect from here because I was doing some work. So this is one that I uh, have on a Azure cloud service. So if I wanted to connect to this one, I would put in my database and then my authentication and hit connect. And then from here, I'm connected to the database. So just to go over some parts, this is specific to SQL Server Management Studio. On the left here, we have our Object Explorer. I'm not sure exactly how big this is on your screens, but this Object Explorer lets us navigate through the database. We could see all the tables that we have whenever this finishes loading. Okay, once this finishes loading, you'll see the tables in the database right here. So we got a categories, customers, employees, order details, orders, and then within that, let's say our customers table, we could see other things. We could see the columns that are in it. In this case, there are a few columns: customer ID, company name, etc. We could see the primary keys. I'm pretty sure these have one. Yep, we have the primary keys. It's called PK underscore customers. And in addition to seeing the tables here, you can also see some other important things. Um, if you're working in a database at a company, they'll probably have views and store procedures. This one has views. So this one has a few views, and I don't think this one will have store procedures. No, there's no store procedures here. And going back to our presentation here. So to start with our query, we're going to open up a new query editor. So we just hit Control N or just hit new query here. And then this is our blank slate to write our query. If you're using Mac OS, you're going to be using Azure Data Studio. Then this is how you would open a new query in Azure Data Studio. Just file new query. So the simplest form of a query, the hello world version in SQL, will be a select star from a table. So in this case, we're just going to do a little quick select star, and then we'll just do it from, say, the customers table. So there's a few ways you could do this. I think good form, or one way that I like doing it, is typing out the database followed by this DBO, which is also called a schema, which we'll go over next, and the table name. This kind of makes things very clear about what table you're trying to get to, because sometimes on a server, you may have multiple databases, like in this case, or not in this case though. In this case, we just have BDAC. You may have multiple schemas, and there may be multiple customers, or there may be a customers table in different schemas. So writing it out fully like this is, I think it's good form. Uh, you'll probably see a lot of, but since we don't really have multiple databases, multiple schemas in this, a lot of times you'll just see me doing shorthand, just going BDAC, or just going to from customers. And that works as well because this is smart enough to know that when you say customers, you mean this DBO.customers, because this is the only customers table in here. And one thing to look out for too, like that kind of gets a lot of people. When you first connect to a database, a lot of times it'll default you to, okay, well, it's not showing here. But in this example here, my screenshot, you'll see, oh, that doesn't work. I'll do this. You could select a your database right here at the top. So in this case, by default, SQL Server Management Studio brought us to master, but you want to change that to select BDAC in this case. You'll see here, if we left it at master, it'll just give us an error saying reference to database and our server name is not supported in this version. And that's all you need to do to fix it. And the way you would fix that in Azure Data Studio would be at this little drop down at the top. Okay, so Now we're going to go. Now we're going to go over all the different clauses in SQL. So we have the select clause. So a select star returns all the columns in a table. So every column. And then if we wanted to return specific columns, we will have to individually name them in our select statement. So I'm just going to copy and paste this example here into our query. And you'll see here that we're asking it to select the column names, company name, address, city, region, postal code, and country from the customers table. And that is exactly what we get. We get all the rows and just specifically these columns that we mentioned to them. Another thing that you could do as well, this is kind of personal preference to me, but I think it's pretty handy to know, or it's something handy that I do, is kind of the formatting. You know, you don't have to write all of your columns in one line. You can separate them onto multiple lines like so. This is the way I like to do it, just because if I'm ever modifying the query and I need to just say remove, let's say we don't care about region, I could just delete that from there, and then we keep it simple. Or I could even just comment it out like so. And we'll go over comments in the future as well. But this is the way that I like doing it. Some people like to do it this way as well, which is just as valid. They do the comma like this. I mean, this way works probably better because I could delete this very last one and not cause any issues. Whereas if I had the comma at the end, like so, it would do something like this. And then you would have to delete that last row and also remove that comma at the end. But that's just my personal preference. So continuing with the select clause, there is something we could do in there called distinct. And what this will do it will return the unique values in that column. So in this case, let's say we wanted to find out what countries we have customers in, right? So we want to select unique countries from the customers table. So I'm just going to copy and paste that into here. And then you'll see in our customers table, we have customers in all of these countries right here, 21 countries. And that's just a screenshot showing you the example. So next is the from clause. So the from clause indicates which table we will be pulling the data from. Okay, so in the examples we've done in the so far, we've taken them from the dbo.customers table. So going back to something I did earlier, we have our comments. You could do a single line comment by using 2 dashes, or you could do a multiple line comment by adding a /* at the start and then a */ at the very end. So this is useful for explaining what a certain query does below it, or if you just wanted to comment out certain blocks of code for testing. Let me see if I have an example here. So yeah, I have an example right here. So at the very top, I have the double dashes to just comment out a single line of code. And then you can see here, it doesn't affect the query below it. And then below that, I have a multi-line comment. And this could just be like explanation of the code above it or the code below it. Yeah, so that could be that. And you'll see here that only that part is commented out. So the where clause. So the where clause kind of acts as a filter, as a row by row filter of our data. So some things that we could use to filter it are an equal signs, greater than, less than, in if we're trying to filter a list, is null if we're trying to find the nulls in a column, and etc. So in this case, let's say we just want to see all the columns from the customers table where the country is equal to USA, right? So we want to select star. I'll just copy and paste it there. So we want to select all the columns from the customers table where the country is equal to USA. And here we get it. We have all of our company names that are in the that fulfill the USA country criteria that we specified. So continuing with the word clause, we could add other things like if we wanted to find not equal to, you could do a exclamation mark equals to, or we could do a not. If you're doing a not, you do a not in, like not in a list. I guess I should add this too. I think doing a not equal to this way is more appropriate. My DBA bugs me about doing this because I like doing the exclamation mark equal sign. He tells me I should be doing this instead because it's ANSI approved. So I need to start. So this is probably a better way to do it. I mean, that's what my DBA tells me at least. So in this case, we'll just modify this and just say, let's say we want to find our customers not in the USA. And then here we go. Here we have all our customers not in the USA, so you won't find any USAs inside here. So continuing. Now we're going to go over the in and not in. So this is used if you want to filter based on a list that you're giving. So in this example, we're going to select select all columns from the customers table where the country is in this list. And if you don't know, this is the list of countries in the EU. So I'm going to copy and paste this. So this is, let's say your boss comes in and tells you, hey, like there are some new EU changes. Uh, Give me a list of all our customers in the EU so we can see if we're going to be affected or how much we should prepare for this or who should we notify. And here we have a list of all the countries that were given in our list. And let's say if we wanted to find all of our customers not in the EU, then we would just precede this with a not. So we're a country not in this list. And here's a list of that. You'll notice, you see, the UK is not in there. Okay. So continuing with the word clause, we can use other things like and, or, and an or to kind of combine filters, or we could use not or between. So in this case, in this example, we're just going to, let's say we want to find contacts in our customers who are in the USA and they're the owner, right? Let's say we don't care about like salespeople contacts. We just want to find the owners. So we'll copy and paste this into our query. And we'll get this. So in terms of contacts that we have that are owners that are in the USA, we have these two. Whereas if we didn't have this, I'll comment this out. We'll see, we have some other contact titles for a sales rep, a marketing manager, sales manager. Let's say like, we didn't really care about these. We only wanted the owners. And that's where you would use this and. So next we're going to go over nulls in a table. So nulls are empty values in the table. They are not zeros. They are not blank spaces, like in this case, just two single quotes. They're not blanks. They're not zeros. They are non-existent. I believe we have a few examples here. Yeah. So in this case, a fax number was never input for this record. So therefore it came back as a null. So depending on the column that you have, Nulls may or may not be allowed in a. For those of you who are taking database classes, you'll know that nulls are not accepted in a primary key column. Like let's say order ID or customer ID, you can't really have a null in those. But then you have some times where nulls may be allowed, like in this case, fax machine, a fax number. Not every company has a fax number. Um, and if we set this column to not to be null, like let's say no matter what, you have to put a fax number in there, then people are going to start putting in like gibberish, like 999, 999, 9999, or something like that. And that would be more harmful than useful in your database. So when we're using it in a where clause or a having clause, uh, we're going to use is null to find null columns or is not null to um, return columns that do have something in that, to return rows that do have something in that column. So just as an example, in this customers table with a fax machine with the fax number. So let's say we want to find where a fax is null, right? So let's say, we really want to get fax numbers for everyone. So we want to get a list of customers so that we could call them and get their fax number. Well, here we go. We have 22 records where we don't have fax numbers. And let's say, we need to send out a mass fax for some reason to all of our customers, and we need to get a list of all that. We would do a is not null. So where there is something in the fax column. And then here we go. We have a list of 69, nice, that have fax numbers. Okay, so the like operator. So the like operator is like using a search, in a column for a certain pattern, typically used in our where or having clause. So a like can use wildcards like the percent sign and the underscore. So the percent sign will match 0, 1, or many characters after or in a text. So just to show you an example here, I want to select all columns from the customers table where the contact title is like, and then it's going to start with sales, and then we're going to have 0, 1, or many characters after that. We don't care what's after that. So let's say we want to find just anybody in sales. So if you look here at our contact titles, we have sales reps, we have sales agents, sales associates, all of these sales managers, all of these different salespeople. So continuing with that, the underscore will only match a single character or will only return um, columns that have that many characters after whatever pattern is. So let's say some really like arbitrary law came into effect where any let's say make a region here. Okay, where any region that starts with the letter W is going to have like extra taxes on it or something ridiculous. Personally, I haven't found many uses for this, but let's say just for an example, we're going to find anything that starts with a W and has only one character after it. So in this case, we have I'm sorry, really bad my states, Washington, Wyoming, right here. And just to show you another example of how that works, I'm just going to do contact title, like, and then sales, sales agent. So sales agent has what you have sales space AGENT. That. So you'll see a return sales agent because after sales there are 1, 2, 3, 4, 5, 6 characters after it. And you'll notice if I remove one of these and ran it again, we'll return nothing because there's no value in that column contact title that has the word sales followed by five any characters. We don't have anything like that. And this is just an example showing that. So one of the more powerful things you could do with SQL is calculations. Um, so calculations can be done in the select statement as long as both of the parameters are numerical. So we could do numbers calculated on columns. In this case, we have 1.10 times unit price. Unit price is the name of one of the columns we have, and it is a numerical type column. And columns can also be calculated on other columns. So you can have unit price, which in our table is a numerical data type, multiplied by quantity, which is another numerical data type in our table. So then this is just an example here of doing that kind of a calculation. So let's say from our order details table, we want to return the order ID, the product ID, the unit price, the quantity, and then we want to multiply 1.10 times the unit price, because let's say we want to start marking up everything by 10%. Oops, not that. Oh, you'll notice what happened there. So I accidentally had this highlighted. So when you highlight something and you hit run or execute, it'll just try to run whatever you highlighted as code. And obviously, if I just do unit price, that's not going to return anything. So you see here, right here, we have all the columns that we specified plus 1.1 times the unit price. So 14 times 1.1 is 15.4, and etc. going down. And these are just further examples. So the cast function. So the cast function is pretty neat. So just as an example to show you how it works, I'm just going to do a little bit of math in here. So 5 over 4. So all of us know 5 over 4 is 1.25. But if we try to calculate this, I think I do a select. It returns 1. Now, why is that? That is because these are both integers that you're passing. So an integer dividing by another integer to SQL Server Management Studio is going to return another integer, in this case, 1. So how can we fix that, right? So what we're going to do is we're going to do the cast function to transform one of these to something else that could have decimals, and like a decimal data type, for example. So the general syntax for a cast is you're going to have select cast, and then whatever your expression, whatever it is, in this case, it would be 5 over 4. And we're going to cast that as a data type. So these are some data types. We have varchar, numeric, date, int, big int, and a whole bunch more. I think we have another list here. Yeah, these are some more examples. So I'm just going to show you an example here. Actually, I'll do it with this one. So let's say we're going to cast, I'm only going to do it for one of these. So we're going to cast this one as just say a double, or yeah, double. One second. That. Oh no. Let's try to text decimal. I get my data types mixed up sometimes. Okay, here we go. So in this case, we're dividing 5 as a decimal type, which could take decimal places, divided by 4, and then we get our correct answer of 1.25. So it works that way. Another thing we could do is just do a 5.0, because 5.0 is a decimal data type. Divide that by 4, we get the same answer. So that's both ways you can do it. And these are just some more examples of different data types. A bit goes from 0 to 1, it's either 0 or 1. Tiny int goes up to 255. Small int has this range, int, big int. Understanding data types is pretty important, especially if you're say you're going to create a table. If you're going to create a table that's going to store like revenue data or something, you probably don't want to use something like tiny int that only goes from 0 to 55. You probably want to do something like big int, or maybe even like a decimal. And so just as a further example, on decimal, because let's say on this one here, right? We got 1.25 and a bunch of zeros after it. So let's say we wanted to clean it up, and we wanted to specify how many decimal places were after it. I'll show this example right here. So we're going to return order ID, product ID, unit price, quantity, and we're going to return that back as a decimal, and then we're going to pass these two arguments into it. Oops, not that. So what this tells us here for decimal, it consists of two things. The first number is the precision, and the second number is the scale. So in this case, we have 10 and 2. So 10 tells us how many digits we could have. So we could have a total of 10 digits. And then the 2 afterwards tells us, or tells the program, how many decimal places after the decimal we're going to have. In this case, we're going to have 2. So let's say if I modify this to say 4 and run that, we would have 4. And let's say if I just wanted to be really messed up and just say like I wanted 1 digit total, I don't know how that would look. Yeah, that wouldn't even look like anything. Say 3. Yeah, that doesn't even work. I mean, you would never do that anyways. Okay, so next, just continuation on different data types. You have your dates, your times, your date times, uh, and there's just further information for you to know or to look up. So now we're going to go over aliasing. So aliasing is a way for us to give a column or a table a temporary name. All right, keyword here is temporary. Um, the name that you're going to give it isn't going to be stored on the database. You're not going to be changing anything in the table. This is just something that you're going to be giving it temporarily in your query. So the general syntax is you're going to have your column or table name, and you're going to have as followed by whatever you want to name it. The as part of this isn't always required. However, it helps with readability if someone else were to look at your code. So example here, we could do quantity as, let's say we want to shorthand it to QTY. If we had unit price times quantity, we could call that as revenue, or I could do unit times quantity and just not put anything after that and just put revenue. These will both do the exact same thing. And let's see, do I have an example here? I'll do this as an example. So see from this previous query that we did, if you look at the table, it says no column name because it doesn't know what to call it. We took 1.1 times unit price. Doesn't really know what to do with that. So let's say we want to alias it as, say, unit price markup. Fix that and right there. So if we run that, now this column is called unit price markup. Now, this didn't change anything on the database, remember? This is just for the purposes of our query. And just to show you that you don't need this as after it, I'll take that out. And it still works. It still aliases that column as unit price markup. Okay, so now we're going to start going over count clause. So the count function can be used to count the number of non-null rows in a table that match a specific criteria, or that can match a specified criteria. So in this case, let's say we just wanted to find out how many products we sold. So we're going to do a count star from products. So this will count pretty much all the non-null rows in products. In this case, we have 77. So we have 77 total products. Now, that's kind of useful. Let's say in this other example, we're going to pass into count distinct countries in our customers table. So what does this do? So what this will do, this will look at our customers table, and it will count how many distinct countries we have. Now remember distinct from before, distinct is unique values in the country column. So this is going to count how many unique countries we have in our customers table. So in this case, we have 21 unique countries in the customers table. And we could even double check that if we want by just removing that count. Oh, and moving that too. And you'll see we have 21 distinct countries. So now moving on to aggregate functions. I guess that previous count was also an aggregate function. So we could do aggregations on our data as well. AVG is used to return the arithmetic mean of a column, excluding null values. So in this example, let's say we just wanted to find the average unit price of all of our products, from all of our products. So taking the average of the unit price from the products table, we get 28.8663. And min max will return the minimum value or the maximum value in a column. So going back to our products table again, let's say we wanted to find the max unit price. What's the most expensive product that we sell, right? It's $263 or whatever, 263.50, in USD, euros, whatever it is. And say the cheapest wine. We do a min. Cheapest wine is 250. Now the group by. So the group by clause is used in conjunction with aggregate functions like the count, max, min, sum, or average. As you can see in the previous example, I'll just continue with this. Let's say go back to max. Just knowing the max price doesn't really tell us much. Let's say if we wanted to know exactly what the product was, for example. So in the products table, what do we have? We have a product name. So let's say I didn't know know about the group by function, right? So let's say I wanted to get the product name and, or sorry, I want to find the product the most expensive product and return that product name, right? And let's say I don't know about the group by function. Well, if I did that, then it would return this error. It was saying, it says the column product name is invalid in the select list because it is not contained in either an aggregate function, like our min max average sum, or in the group by clause. So I will need to add a group by and then add product name to that. In fact, I don't think this will work. No, that won't work because I'm grouping it by product name. Bad example. I'll use this one instead that I have. Okay, so in this case, we want to find the number of customers per country. Okay, so we're going to group our rows, or we're going to group countries together, and we're going to find, and we're going to do a count of the number of customer IDs in each of these groups. So in the customers table, we have 3 customers in Argentina, 2 in Austria, 2 in Belgium, and so on and so forth, going down the list. Okay, so now we're going to go over the order by clause. So this is used to sort results by a column. So by default, it'll do ascending order. But if you wanted to do descending, you would use, DESC for descending, Or if you want to just explicitly say ascending, you would do ASC. And you could have multiple columns. You could pass multiple columns into it if you wanted to do multiple sort levels. So going back to the previous query, knowing this is nice, but let's say we just wanted to order it by the customer account. Do it order by. And then we just type in customer account. Let's say we wanted to order by descending because we only care about having the country that we have the most customers at the top. So in this case, we just ordered it by customer account. So we can see US, we have the most customers in the US followed by France and Germany, Brazil, UK, etc. going down. Okay, so the having clause. So the having clause is very similar to the where clause, except it is used to filter an aggregate function. Okay, so just an example here. This one, going to this example here. So let's say we want to just find the countries where we have more than 5 customers, right? We don't care about anything that has less than 5 customers. So we will say having, whoops, count of customer ID greater than or equal to 5, right? So then right there, we just filtered on an aggregate column, in this case, our customer account column. So this is different from the where clause, whereas a where clause does row by row filters, right? It'll go through each row and then filter out each of those rows out. Whereas if you want to do a filter on this aggregate column, right, this count of the customer IDs, you will have to use the having clause for that. So a very important distinction, okay, that you guys need to remember. And something that will probably trip, well, that some interviews may try to use to trip you up. So now we're going to go over joins, which is very important. So what it does, it combines 2 or more tables or queries based on a related column between them. So in a relational database, we're probably going to be dealing with a lot of joining of tables because these are all tables that are related to each other in order to get any kind of meaningful data out of it. So the general syntax is we're going to have a select, and there's going to be a star or whatever your list of columns from the first table, join with another table, and then on, and then this is where you're going to specify how those 2 tables are going to be joined, right? So you're going to say typically you're going to have table 1 dot column name is equal to table 2 dot whatever the column name, whatever primary and foreign key are joining those 2 together. And so this is just kind of a diagram that I really like that kind of goes over all the different kinds of joins that we could have. So your typical join, the one if you just typed in join, like in this example, we just did join, would be an inner join. And so it would only return records where we have a match in the keys. So this little inner portion. Now a left join will return everything from the inner join as well as everything from the left side. So if you're trying to figure out what's left and what's right on a left and right join, left is the first table that you mentioned, in this case from table A, and the right side is going to be the second table that you're joining with, in this case, table B. So you'll see here on the right join, same thing as left join, except for the right side, the right table, B. These ones here, we don't use, probably won't use as much, like this one here, or this one here, whoops. probably won't use as much. Um, but these will, in this case, we go to a left join where the b dot key is null. So it's just going to return just the left side and not return the right side, nor return anything that even joins with the right side. And then here we have a full outer join, which is just saying, hey, just dump like like uh, all the matching rows from both of the tables, as well as everything that doesn't match from the left side and everything that doesn't match from the right side. And then this one here, I've never used this one, but this is the syntax you would use if you wanted to only if you want to return data from both tables, but exclude anything where they match together. So just an example, to show an example here of a join, we're going to join two tables together. And I'm just going to just clean this up a little bit here. Okay. So we're going to join customers with orders because we want to get the name of the company as well as what order ID and what date they placed the order. All right, so we're going to join customers with orders, and this is just something that makes things easier. We're going to alias the customers table as CS, and we're going to alias the orders table as O to make this part easier. Because without this, if we didn't have these aliasing here, then we would have to actually type out customers and actually type out orders, which is kind of cumbersome, honestly, and also do the same thing here, like orders, and nobody wants to do that. It's much easier to just alias it. And sometimes you may see some people just do like alias these as A or B and just go like that. Personally, I like aliasing them so that they kind of indicate what table you're pulling it from. So I like to alias customers as CS, orders as O. It makes it a lot more intuitive when you're looking at these. Like if I look at, oh, company name. Oh yeah, I got that from the customers table. Or order ID, I got that from the orders table. So running this, we would get all the company names from the customers table and their matching order ID and order date from the orders table. So continuing on with the joins. So we can use, in this case, we're going to use multiple joins to calculate the total orders. So I'll just paste it here. I think it's a little more readable. So we're going to get the customers table. We're going to use the customers table to get the company name. And I think I'm just going to do this real quick to make it a little more readable. Once again, like going back to what I mentioned earlier about making it more readable, instead of having all these on one line, it's a little more readable to put them on multiple lines. Oh, I missed one. Okay. Because in this case, we're going to get the company name from the customers table because we want to know the company name. We want to know the order ID and the date it was ordered. And you notice here where we didn't like before how order date was in this format, like a date time format. We don't care about the time the order was placed. In fact, they're all zeros in all of these. So we're just going to change that to a date format, a date data type. So that's just the date, no time. And then we're going to do the this calculation here, unit price times the quantity minus any discount, and that's going to be the total. So if we run that, got it here. We have the company name from the customers table, the order ID and order date from the orders table, and then from the order details table, we are getting the unit price and the unit quantity. And I believe discount is also in there. Yeah. And you'll notice, without having to alias this, this still worked. Um, some cases you'll have to, some cases it knows that I didn't have to, sorry, I didn't have to put, yeah, the OD period in front of this because the program knows that there's only one discount in these three tables. So it knows to use OD dot discount and nothing else. Whereas if I did it with, say, order ID, that wouldn't work. It would say ambiguous column name order ID because there are multiple tables with an order ID. Order ID is in the, I believe it's in the orders table and it's in the order details table. So it says, hey, I don't know which one, I don't know which order ID you want. You want the one from the orders table or the order details table, which is why we specified here. Okay, so continuing on, that's just the example there. Okay, so just to kind of give you guys a visualization uh, on how the different kinds of joins work, I have this little example right here. So this example here would be a full join, right? So, or let's say this. We have the left side is our first table, and then the right side here is our second table, right? So first table and second table. Let's just do this here. First table is that side. Second table is the other side. This is the second table, all right? So this will be a full join. It would return everything that's joined together from these two tables, as well as all the data that doesn't join from the left side and all the data that doesn't join from the right side. And in the next example, this will be an inner join. So only return rows from both tables where they join together. A left join would return all the, once again, all the rows that joined together and all the stuff from the left side that didn't join with the right side. And then the right join, similar thing, all the data that joins together here at the bottom, as well as anything that didn't join from the right side as well. So unions. So unions are used to combine columns from two tables, to kind of stack them on top of each other. So they can be used they can be used to return duplicates or not via union all and union respectively. So union all would include duplicates and union would not. So they must have so a couple of criteria. It must have the same number of columns and they must be the same data type that you're stacking on top of each other. So just an example here, we'll take two queries and I'm just going to separate this a little bit. So we want to get all the cities from our customers table, right? So these are all the different cities we have in our customers table and all the different cities we have from our suppliers. So we have a city, cities of our suppliers and the cities of our customers. And let's say we just wanted to combine them together because we wanted to know, hey, like what cities do we have exposure in, right? Either cities we have customer exposure or cities we have supplier exposures. So if we run that, you'll see right here, these are all the cities that we have customers or suppliers in. And you'll notice here when we do a union, it doesn't include any duplicates. These are all unique. Whereas if we did a union all, it would include duplicates like multiple Buenos Aires, multiple Londons, Madrids, etc. Okay, so this is just a sample SQL interview question that you may get. I know when I interview people, I kind of give kind of a kind of a question similar to this as well. So this is in fact, this wine here, yeah. So this was actually a wine that when I was at a career fair back back when I was doing my master's program. Uh, at a career fair, somebody asked me, or they saw on my resume that I knew SQL, that I was, pretty knowledgeable about it. So they just said, okay, you know, write me a query. So give me a query containing the company name and the total revenue for all the companies with total revenue greater than 10,000, right? And he said we have three tables. You have a customers table, an orders table, and an order. I guess it'd be order details table. Let's call it order details. So then this is pretty much the query that I wrote. In fact, on the bottom right, this is the actual query that I wrote freehand while he was talking with other people. So we have can I use this here? No, I don't think I use that here. So I'm returning the customer name, the sum of all the prices as total revenue from our customers table, joining with the orders, joining with orders, orders ID, grouping by customer name. And so this was the main thing that he wanted to try to catch, right? He wanted to make sure that I didn't try to do a where the sum of this, where the sum of our total revenue is greater than 10,000. He wanted to ensure that he was trying to catch me putting this in a where clause instead of having, because remember, if you're doing a filter on an aggregate column, in this case, sum of OID price, then you're going to want to put that in a having, not a where clause. And then I just did it by descending right there. Ordered it by descending. Okay, we got time. So this next part is kind of a more of an advanced SQL thing. So we have something called window functions, right? So this here is just a definition that I got online. So a window function performs a calculation across a set of table rows that are somehow related to the current row. I know, I'll explain. I'll show you an example. So this is comparable to the type of calculation that can be done with an aggregate function, but unlike regular aggregate functions, use of a window function does not cause rows to be grouped into a single row output. The rows retain their separate identities. Behind the scenes, the window function is able to access more than just the current row of the query result. So, it's kind of confusing. In fact, this probably looks more confusing, but I will explain and show you. Okay, so I'll go over this step by step. So we want the company name, the order ID, and then here we're going to start doing some aggregations. So we're going to take the sum of the unit price times quantity, or the order revenue, and then we're going to take the same thing, that same calculation, except we're going to do it over, and we're going to use this over thing. So this over partition by, that is the windowed function part. So what this says is we're going to calculate the order revenue, but we're going to calculate that for over a group of company names. If that makes sense. I'll just run this query right here. So let's just take this first group, right? So this partition by, we're going to partition it by company name, right? Which means we're going to group it by company name. So this order revenue takes the unit price times the quantity for this order, right? But when we do it over here on this other line, sorry, on this line here, we're going to do the same thing, unit price times the quantity, except we're going to group it by company name, which is right here, this column right here. So this is going to take, so this here is pretty much the sum of all the order revenues but done for each company name. That's the partition by company name part. So you'll see here for this one, this Alfred's, we're passing the total revenue. This total revenue part is just for this company. This revenue is just for this company, and so on and so forth going down. So that's the windowed part of the window function. And then here, we're just going to do a calculation. So it's going to take, sorry, so this line here is just going to be a calculation. It's going to be the order revenue for that order divided by the total revenue to get the percentage of total profit. So this order ID 10692 has $878 worth of revenue out of a total for that company of 45.96, which is 19.10%. So then that's the window function. So now we're going to go over subqueries. So let's say in that previous query, right? Well, actually, I'll go over subqueries first. So subqueries is pretty much a query within a query, right? So an easy way to explain it, this query, when we run this query, we look at the results here. I mean, what is this, right? This is just a table, okay? So if you think of a query as a table, and you're going to run, so you're going to run a query on that table, which is also a query, right? If that kind of makes sense. Let's say we're just going to run a query on this table right here. So in this example, so let's say we want to find orders that are greater than or equal to 10% of a company's total profit. So let's say we want to take a query of this table where this percent of total profit is greater than 10, right? So then for that, we will use a subquery for that. In fact, I'll just type it out here manually. So we're going to select star, so return all columns from, and then we're going to have our subquery right here. And this is just a little formatting thing that I like to do, right? So we're going to do so this is very familiar, right? Select star, select all columns from, and instead of taking it from a table, we're taking it from this query that we just ran, right? And we're going to do it, I want to find out where percent of total profit. That's right. One thing you have to do as well, you have to alias. If you're doing a subquery, you have to alias it. In this case, I'm just going to alias it as A. And we'll take A dot percent of total profit. Wait, I mistype it. Okay. Where percent of total profit is greater than 10%. So if I ran this, oops, sorry. Oh, right. You can't have an order by clause in a subquery, so I'm going to take that out. So if I ran that again, there we go. We successfully ran our subquery. We ran a query, which is this whole outer part, the select star from, where percent total profit is greater than 10. We ran a query on our subquery right here. We ran a query on another query, right? Because the query is just nothing but a table. And this here is exactly what we did in the previous example. So now that we have, so let's say we started running this query, and let's say, you know, our boss likes it, right? It's like, hell, this is great. You know, like, can I get this sent to me in an Excel report like every day? Okay, well, you know, obviously it's the reproducibility is there. Like whenever this updates, all I need to do is just open up this query and rerun it. But let's say we want to put it into an Excel report. You know, like let's say we don't want to just, you know, last thing you want to do is copy and paste this into an Excel workbook, and then just send it over to your boss every day, right? You don't want to do that. You want you kind of want to make it a little easier for them. So there's something we could do. We can connect SQL. We could connect an SQL database in Excel. So these are the instructions on how you would do it. You would open up your Excel. You would get data from. In this case, we're getting it from an Azure SQL database because this is where my database is located, or this sample database is located. You would probably be doing it. In fact, I'll show you here. You'll probably be getting it from a database and probably from an SQL Server database. Or, I mean, God forbid, if your company is on Access, or from SSAS if you got it, or maybe your company is fully in the cloud, in which case, yeah, you would use an Azure SQL database or SQL warehouse. But for our example, I'll just do an Azure warehouse, and I forgot what the server was. Jackson Vita. Hold on, let me just go back and just copy and paste that. Okay, so that's the server. Database is BDAC, and so what I'll do, I'll connect to the database, connect to this, or sorry, connect to the server, connect to this database, and then it will run this SQL statement. So we're just going to grab this, copy and paste that into here. And then when we hit OK, it'll connect to the database, run the query, and then return exactly what we ran before. So in this case, we're going to load it. And right there. Now this is the output from that database. And now whenever, let's say your boss wants to refresh it, they just open this up, go to data, and just hit refresh all, and it'll run the query against the database again, and it'll provide updated information whenever they need it. Right. So that's a pretty handy. It's pretty handy way to connect your Excel workbook to a SQL server to get updated information. And then from here, they could even decide they want to just do a pivot table on all the data, right? And they could just build a whole report just off of this data, They could just build whole reports off of it, and all they would need to do is just hit refresh all and just update a whole report. So I found that to be pretty handy, and also pretty impressive for end users that may not know about this, that may not know SQL, or may not know about that they connect their Excel workbook to a SQL database. So some useful resources if you want to learn. There's Code Academy. You can learn w3schools.com, which is really awesome. I like that a lot. SQLzoo.net, and also just plain old Googling. Googling is very important to learning, I think, anything programming related. And these are just some examples on here that you guys can look at. I have a criteria and then the query running against it. So I provide all these use cases just as examples because I found when I was learning, when I started my internship, I knew a little bit of SQL, but not a ton. But I found that just looking at other people's queries helped a ton. Like I learned so much reading other people's queries. So since this database won't be available forever because I pay for this out of my own money. It costs a few bucks every time I do this. So after this, I'll be closing it. But if you want to create your own database to practice all of these queries that I ran, as well as going over these sample queries, the instructions are right here at the very end. You would just need to install SQL. This is all free. You would just need to install SQL Server 2017 Express for free. Install SQL Server Management Studio or Azure Data Studio if you're on Mac OS. you download the Northwind database file, which will be a query essentially. And then when you run that query, it populates your database. And if you want to practice with a different database, or so the one I use here is the Northwind database. But if you want to practice with another one, there's also the AdventureWorks database. Yeah, you open the SQL file for either one of these databases, and then you hit run. And then when you hit run, it just populates your database with like creates all the tables and puts in all the data and everything. Uh, oh yeah, that's right. If you're and uh, you have to create an SQL server on your local machine. So unfortunately, you can only do that with Windows and Linux. That's what this SQL Server 2017 Express is. As far as I know, my research, I haven't found a way for Mac users to create a server on their computer. I mean, maybe if they like dual boot something, dual boot Windows or something maybe. Um, but oh wait, you know what? Oh, sorry, I did find one. Sorry. Yeah, so there's one. There's a way for Mac users to create a server. They just need to go to this link right here. And with that, I believe that is it for me. Here's my contact information. Feel free to email me or add me on LinkedIn. This jacksonleung.io is a link to my LinkedIn page. Uh, jacksonleung.com is not me. That's some other guy named Jackson Leung who is also a data guy and stuff, but he's not me. Um, and yeah, with that, pass it back over to Kevin.
Super cool workshop as usual. One of the cool things that I want to know is that connecting the SQL database to the Excel sheet, because we did our was it last week or was it 2 weeks ago? We did the Power BI workshop and we were working with a Excel sheet. So I think that's another way we could do a live data like thing to funnel into the Power BI. So anyone who is there for that, keep that last part in mind that he mentioned, because then you'll be able to get that live connection and it'll be really cool to see that. I'm actually gonna mess around with that and try to see if I could do anything with that. But does anyone have any questions for Jackson? Have any questions? We have Andrew. You can unmute and ask your question.
Hi, Jackson. I had a question on slide 51. When you created an alias, it was in brackets. I don't know if you can you hear me? Okay.
Yes, I can.
Was it in brackets because it would be confused with that aggregate function or the aggregate clause, I mean?
Yes, exactly. Good job catching that. Yes. So yeah, if you have anything that is going to conflict with a built-in command, I guess, to SQL Server Management Studio, you would have to put it in brackets. Like let's say if I wanted to call something date, will date work? Yeah, that's why though. You'll put it in square brackets. Also, if you noticed before, wait, yeah, I am sharing my screen still. I have one called order a table. This table here, order details. There's also square brackets around those because of the space in between right there. So this is very bad form. No one should ever add a space in a table name. But in that case, you would need to put the square brackets around it because otherwise it would just read this as dbo.order and then aliasing as details if you didn't have those square brackets around it. But yeah, good catch.
Yeah, thank you.
All right. Any other questions for Jackson?
Yes, I have a doubt. So, is this bracket uh, like does this work in this particular software, or it is also for PostgreSQL and REST other software tools?
Huh, that's a good question. I think it should work in other softwares. The only software I ever use is SQL Server Management Studio, but I don't see any reason why it wouldn't work with other softwares. Or do you mean other softwares like MySQL or like that?
Yes, yes.
Oh, I'm not too sure. I've never used MySQL or anything else besides Microsoft SQL.
Okay, okay. So uh, like when you rename a column name with alias, is that mandatory to have brackets, or it's just for our convenience to read the code?
No, you don't have to. You can if you want. Um, in the case that we
Yeah,
went
count.
over with the count,
Yes.
we had to with the count because count would interfere. It's also a command or a function as well, so it would like mess up the query. Um, Typically, you'll find out because because if you try to run the query, it'll give you a big angry red message saying, "Hey, you messed up." So yeah.
Okay, yeah. Thank you.
Just to add to that about syntax, always look it up for the specific language because though SQL is pretty much universal and like what it is, sometimes different softwares might require you to type something specifically. So just always Google it if you're ever unsure. But any other questions?
I got one question.
Okay.
Oh, okay,
Okay,
I will
sorry.
go Yibo
Go ahead.
first and then Swati.
Okay, thank you.
Yeah.
So I think my friend like Zihao told me before a lot of people are using MySQL, but in my 402 class, the professor taught us the SQL the Microsoft version SQL database, like the SQL Server. So I'm just wondering like which one is more universal to use.
I think Microsoft is just because I mean
Oh,
it's Microsoft and like every and they're huge. Like every like a lot of big corporations use
okay.
Microsoft. Um, yeah, that's my opinion. I've never looked it up. I've never looked it up really, but that's my gut guess. Microsoft is huge. So
Okay.
yeah.
Do they have like do they share common syntax or they have like a little bit difference between Microsoft Server and MySQL?
Yeah, so I've never looked it up specifically. I know there are some differences between
Oh,
MySQL and Microsoft SQL, like the way you write it. But I mean, just like with learning any programming language like R or Python, I mean,
mhm.
if you understand one pretty well, it's not that difficult to learn the other. And I think the same would go for Microsoft SQL and MySQL.
Okay. Thank you very much.
Yeah.
Okay, Swati next.
Hi, Jackson. So you did mention like a couple of resources where we can practice SQL, but then I mean I know there's lead code, but then are there what like if I were to practice more intermediate SQL or just just to get my hands dirty, other than those, if there's anything else that you would recommend?
Yeah. So yeah, that's an unfortunate thing. Like, it's something that I talk with an interviewer about, and just with my bosses about as well, my managers as well. Like in school, they don't really like make you go that deep into SQL, like get your hands that dirty, unfortunately. And from what I've seen online, not a lot of the things online as well let you do it. Like if you wanted to do window functions, there's not a ton that try to train you on it. In my opinion, uh, going to the last slide with creating your own database on your computer, um, having the Northwind database installed and the AdventureWorks database, and then just going inside there, looking at the tables, kind of creating your own queries, like answering your own questions. Like look at the data, and then just try to figure out something you want to do. Like, hey, like I want to rank the highest, um, the highest like revenues for this product, and just playing around with that. I think is the best way to learn. Like unless you're interning or working for a company uh, that gives you access to their database, and then you can practice with their database. Um, yeah, that's the way I would. That's how I would do it. and that's essentially how I kind of learned as well. I got my hands dirty by getting I had an Excel report that was sent to me every week, and I used Microsoft Access to just create a database on my computer, and I worked on uploading all the data and then creating queries on that data in Access to create reports. But that was just something that you just got to find data where you can and just practice with it. Um, and the Northwind database and the AdventureWorks database are two okay databases to learn from. It's not super complicated, but it's complicated enough to get your hands dirty, I think.
Okay, that's a good suggestion. Yeah, thank you so
Yeah.
much.
Yep.
Yeah, adding on to that, I think that comes down to anything with programming. You basically have to do it on your own time because school teaches you basically how to use the tools, but it's up to you to kind of like start utilizing it for yourself and start working on it on your own time. So if you again, if you guys ever want to just mess around with like certain things, like Jackson, he provided those resources for SQL, and then there's also the resources for Power BI, which is Kaggle, that I usually recommend to people who want to get introduced to that. You just have to go through and find something that you think is interesting and just mess around with it. It usually helps that you have a bit of background of the information or of the data that you're working with. So just keep that in mind whenever you work on stuff and want to learn. Do we have any more questions?
I'll also field any questions if you have any questions about like data analytics or data science or anything as well, since I'm here.
Mm-hmm.
Or on Slack.
That too.
Afterwards.
I think there was, oh my god, as Miri asked in the chat if you'll be giving us the PowerPoint, access to the PowerPoint, so we could
Oh yeah. I don't.
you could
I've
just
never.
download it and send it to me if you want.
Oh no, I have a link to it.
Oh, okay.
I'm really bad with. I don't know how to use Zoom. I know. I feel
Oh, it's okay.
old person whenever I don't know how to use these. But I mean, this link has my PowerPoint always available. Um, I just have
Oh,
no
okay.
idea how to
Just
share it in the chat.
do you see the chat? Are you in full screen mode where like the
I
mic
am.
stuff? Okay, so at the top of the screen you should see like mute, um, camera. Do you see that?
Yep.
Okay.
And
On the
then
right there should be more, like the three dots,
there it is. I
and then
see
you
it.
click chat. Yeah. Awesome. There it is. Oh, he was able to get it too.
Oh yeah,
Awesome.
Andrew got it. Awesome.
So yeah, I'll take this and then I'll probably add this to the email for our students. I'll put it in the board chat for now. Replace the reference. But yeah. All right. Other than that, any more questions from anyone? It could be anything. This is your time. Competition, data analytics. All right. Okay. Well, thank you, Jackson, for coming on as usual. I always find this workshop really helpful and refreshing. So thank you. And there was also new stuff too. So it's pretty nice to see that as well. But thank you so
Yeah.
much.
Yeah, a little new thing.
Yeah. Okay. So I will be ending the recording.